Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review right-angled trigonometry. So for right-angled triangles, when you're using trigonometry to find a side or an angle, use the acronym SOHCAHTOA. That tells you which ratio to use. So sine, cos, or tan. You use sine when it involves the opposite and hypotenuse, cos when it's the adjacent and hypotenuse, tan when it's the opposite and adjacent. So whichever one's listed first goes on top. So sine is opposite over hypotenuse, for example. So when you're finding a side or angle using trigonometry, your first step needs to be to determine which ratio. So let's look at this triangle here where we're finding an unknown side. This side here, the shorter side, is adjacent or next to the angle. So x is the adjacent side and 8 is the opposite side, the side that is facing the 40-degree angle. So the ratio involving opposite and adjacent is tan. We're going to use tan here. So we set up our equation. It's tan of angle equals opposite on top, opposite over adjacent. So in this triangle here, we have the adjacent again, x is adjacent, but 10 is the hypotenuse. Hypotenuse is always the longest side, always facing the right angle. So when we have adjacent and hypotenuse, we use cos. So we set up our equation, cos of angle equals adjacent over hypotenuse. So here we have two equations that need solving. So when the thing you want to find is on the bottom, you divide. When it's on the top, you times. What I mean by that is in this equation, to get x by itself, it'll actually be x equals 8 divided by tan 40. I divided because x was on the bottom. Whereas in this equation here, x is on the top, we times. X will be not 10 divide cos 45, but 10 times cos 45. So in this one here with the cos, I know that you won't be able to do this in your head, which is fine, but what you should be able to do is notice that because x is a shorter side, your answer needs to be less than 10. If it's not less than 10, you've done something wrong. Probably you've divided when you should have times, or you've used the wrong ratio. So you can just put each of these in your calculator. Just make sure your calculator is in degrees mode. So putting 8 over tan 40 in our calculator in degrees mode, we should get about 9.53. Putting 10 times cos 45, we should get approximately 7.07. So in this triangle here, we're actually finding an unknown angle that I've called theta. So your first step is still to determine which ratio to use. So in this case, 3 is the opposite and 5 is the hypotenuse. The ratio we use when the question involves opposite and hypotenuse is, of course, sine. But when you're finding an angle, doesn't matter whether you're using sine, cos, or tan, whenever you're finding an angle, instead of sine, cos, or tan, you use their inverse. You use sine inverse, cos inverse, or tan inverse. So for this one here, I'm actually going to use sine inverse. It's sine with the little -1. Now in most calculators, you have to press shift or second function and then sine to bring up this function. So we always use the inverse when we're finding angles. So what we put in our calculator here, it'll be sine inverse, opposite goes on top of hypotenuse, and you should get about 36.87 or 37 degrees to the nearest degree. All right, let's now look at applying this knowledge to angles of elevation and depression. So a building is 80 meters tall, angle of elevation from my current point is 42 degrees. I walk away from the building till the angle of elevation is 21 degrees. How far have I walked? So if you ever get a worded problem in trigonometry, you really should draw a diagram. So let's do that. So we have our building here. This represents a building which is 80 meters tall. And we're over here somewhere so that the angle of elevation is 42 degrees. Now, angle of elevation means the angle looking up. And angle of depression is the angle looking down. they are always equal in size. So here I've called them both theta because they will have the same value. This is the angle of depression. This is the angle of elevation. It's always the angle made with the horizontal, not the vertical. It's not this angle, that's the angle with the vertical. So we can assume that the building is at right angles to the ground. So we have that this angle theta was 42 degrees. Now what we're told is that we keep walking and then we get over here somewhere and the angle to the top of the building is now 21 degrees. We want to find this distance here, how far we've walked. Now the problem is that this distance here, x, is not part of any right-angled triangles. So how are we going to find it? Well, we have a big right-angled triangle here. Because we have an angle and a side, we can find the length of the other side. We can find this side here very clearly, very easily. I'm going to call that y. Similarly, in this smaller right-angled triangle, we can find this distance here pretty easily, and we'll call it z. So what we'll do is we'll find y, z, and then subtract them, and we're left with x. So let's start off by finding z. So in this triangle here, we have the opposite. We want to find the adjacent. So z is going to be found using tan. Tan's the one we use for opposite and adjacent. So we have tan 42 equals opposite over adjacent. When you're finding the thing on the bottom, you need to divide. So z will be 80 divide tan 42. And then similarly, we could do for y. Y is going to be 80 divide tan 21. So I'm not at the moment finding what this is, and rounding them. That would introduce errors. What I'm going to do to find x is do it in one go. X is going to be y, which is 80 over tan 21, minus z, which is 80 over tan 42. Putting it in my calculator like this will ensure that my final answer is exact. So if you put that in your calculator, you get about 120 meters. That's how far I've walked. All right, let's now look at a question involving trigonometric identities. So trigonometric identities will come up all the time. They're basically equations that are linking the different trigonometric ratios. This here is a trigonometric identity. We're going to show cos of 90 minus theta equals sine theta. So what that means is, for example, cos of 70 equals sine of 20. Cos of 80 gives you the same value as sine of 10, and so on. So how are we possibly going to do this? Well, I said before, if you don't have a diagram, let's draw one. So we're looking at trigonometry and right-angled triangles. So let's start by drawing a right-angled triangle. Now the question involves theta, so I'll just call this angle theta. This will be opposite side, adjacent, and hypotenuse. So of course, if this angle is theta, because these two have to add to 90, because they all have to add to 180, then this one here will just be 90 minus theta. So the question talks about cos of 90 minus theta. So cos of 90 minus theta means cos of this angle here. So cos of the angle is adjacent over hypotenuse. Well, this time the adjacent's marked with O. So it's O over H. But we know that sine of theta is O over H. It's opposite side over hypotenuse. That is literally all you have to do. We've shown that we get the same thing when we take cos of 90 minus theta and sine of theta. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.